Hey guys, this is an intermediate tutorial for A-star pathfinding in a grid-based system for a tile map. Now, looking at this demo, when we click somewhere, it's going to move there and it's going to move inside the tile map, not outside, no matter where we click. So first of all, let's go into this tile map script, and we notice it extends A-star path. And what is A-star path? It's a custom class we're implementing inside of our abstract script called A-star path.gd. And notice that it also extends tilemap. And by inheritance, that means this also extends tilemap. Now, we want to do this because we want to maintain the tilemap functionalities, but we also want to use this A-star path class. You could do this in a different way, but this is just how I like to do it. So line by line, first we assign a variable called A-star, and we set it to an A-star 2D object. A-star 2D is a class implemented by Godot that implements the A-star algorithm. And what this is going to do is essentially get the path from start to finish. Then we have a variable called uCells, which just stores the tilemap getUCells. And what getUCells is, it returns a vector2 array with the positions of all cells containing a tile from the tile set. Note that this is also in the tilemap coordinate system and not the world coordinate system, which is pixel by pixel. Then we're going to initialize a variable called path, and it's not going to have any value to assign to it because we're going to assign it later when we actually calculate the path, right? When we get our two starting and endpoints. But we know that the path is going to be a pool vector2 array, which is just an array for vector2s. So inside of ready, notice we have two functions, add points and connect points. This is just initializing the A-star, right? This is not actually making the A-star path, but first we add points. What this means is what positions exist in the A-star. What can they access? Then we connect the points. And what this means is, can point A go to point B? Can point A go to point C? And we do this for every single point and whichever points that it can connect to. So let's look at add points first. And notice that we're going through every single cell inside of the tilemap. And again, cell is a vector2, right? This is an array of vector2s. So when we get an element from this, it will be a vector2. And A-star is an A-star 2D object, which means we can use A-star 2D functions. And add point is one of those functions. Add point takes in three parameters: ID int, position vector2, weight scale float. Now how this works is, notice how ID, it's an integer, right? Which means that we can't just pass in the position itself as a unique ID. And IDs are meant to allow the A-star algorithm to understand what points we're referencing. Now ID is here, or we're implementing it here. We're using something called a Cantor pairing function, which takes two integers, which is going to be our x coordinate and our y coordinate for the given cell. And then we're going to return a new integer. But this new integer is based on a formula that will give a unique ID that cannot be replicated by any other 2 points. So 0.11 will never be equal to 0.22 or 0.100, and that's how this pairing function works. Now there are plenty of other pairing functions out there, and if you want to, you can use another one. This is just the one I found that is widely accepted and the one that works for me. And then here we just pass in the cell itself, the position of the cell, and then we assign a weight. Now this weight actually doesn't matter at all. We can assign it to actually 100 if we wanted to. But what's important to note about this is that weight would only matter when, for example, let's say I'm at point A and I want to go to either point B or point C. But point B has a weight of 1 and point C has a weight of 2. I would choose point C based on the A-star algorithm because weight means essentially what's better for me. Do I want 2 points, or do I want 2, or do I want 1? And A-star is going to tell me that I want 2. In this case, since we're just implementing a simple tile, right? These when I move from here to here, or here to here, it doesn't matter to me, right? We just choose whatever. So that's why we just have this random here. We don't even need to assign it to 1. We could assign it to anything like I said before. Now we go on to connect points. So now that we added these points, we need to connect these points. So we go again through all the cells in the tile map and we look at the neighbors. And these neighbors are right, left, down, up. Notice something here that when we go down and then when we go up should be positive, right, in your mind. But the difference is that in Godot, if you look here, when we go up, it's actually negative, and when we go down, it's positive. This is because Godot's y-axis is inverted in 2D, so just make sense of that. Now, we go through every single one of these neighbors, and we want to get, right, for every single one of these neighbors, we want to make sure that it's either right, left, down, or up. So let's say cell equal to 1, 1. We do 1, 1 plus 1, 0, which means the neighbor would be 2, 1. 1, 1 plus negative 1, 0. That means it's 1, 1, right? Or 0, 1, sorry. And we do this for all of the neighbors. So now we're getting the points of the specific neighbors. Now we check if the uCells even has this neighbor, which means when we go into this tile map, this obviously doesn't have a up neighbor or a down neighbor. And so we don't want to add these points because they don't exist in our tile map. So once we've made that check, then we can actually connect the points. And connect the points is from the A*2D class again. It takes in a parameter ID int, a parameter toID int, and a parameter bidirectional bool equals true. Now, bidirectional actually doesn't matter for us in this case because we're already taking care of every single neighbor. It would be useful, for example, if we were connecting points from left to right and then we didn't want to have to go backwards, but we're already doing this by going, right and left. So we're just going to set this to false. I think it will still work as true, but that's just the logic behind it. And again, we're connecting this starting cell, which is this, and then the neighbor cell, which is this. And again, we're using ID. Now we've completely initialized the A star, so we can use it properly. We call this function called getPath, which takes in a starting position and an ending position. And then we use the A star's getPointPath, which returns that pull vector to array we were talking about before. And it returns an array with the points that are in the path found by A*2D between the given points. The array is ordered from the starting point to the ending point of the path. And again, pull vector to array is just an array of vector 2's. So it's essentially mapping out all the points we're going to be hitting while we go from point A to point B. This is a little extra thing. You don't actually need it. But the thing is, when you move from point A to point B, it's already assumed that you're at point A, right? Which means that you don't need to move again to point A. You don't have to move from 0, 0 to 0, 0. That's why I do this. But that's the only reason. It's not necessary at all. Okay, so now that we've made this class and it makes sense, right? We can actually use it now. And first of all, we take some input events. And what we're doing is essentially checking for mouse clicks and checking if the circle is the original color, which is white. When it's moving, it's black. So we want to make sure when we click this position, right, we're not able to override it by clicking other places. And we also want to get the mouse input because obviously that's where our destination is. Now, here you'll notice that we're using world to map. And again, since this extends A star path and A star path extends tilemap, we can use the world to map, which is a function of the tilemap class. The reason why I want to do this is because, again, this is implemented with the tilemap coordinates in mind. So we have to make sure that everything we input into our get path is tilemap coordinates. So that's very simple. We just do world to map to convert it. Then we want to check if the tilemap even has the mouse position, right? We don't want to click here and it to randomly just go into the void. So we just make that check. Then we want to do the same thing with of world to map to our circle position, which is our initial position. And then we call get path, where our starting position is the circle position and our ending position is the mouse position. And then we move. Now, this is not that important right now. All it's doing is setting the circle to black while it's moving, and then setting the destination tile to this green tile actually. But this is just for visual purposes. It has really nothing to do with the A-star path. So here we're going through every single point inside of the path. And again, the reason why we can use path, even though we don't have like a path variable in here, is because we're extending A-star path, which means we also extend these variables. We extend everything. This is why it's kind of useful to extend it like this instead of, creating a new object like that. Then inside here, every single path, we're just setting the circle's position to the next point in the path. And that's why you can see it traveling right from point to point very fast. We also have this just for demonstration purposes. If I don't have this here, it's just gonna teleport. And it's really like, even though I'll tell you that's working, you can't really see it visually. Okay, and then this is just setting the tile color back to normal. You can see here when it reaches the destination, now it's red and it's white. So that's pretty much it. That's the gist of it. A-star 2D is there's an A-star class for 3D, and also if you're trying to implement something that's non-grid based, it's pretty much the same logic again. Just go back in the video and try to understand what I'm saying. And yeah, that's pretty much the video, and thank you guys for watching. I hope you guys learned something about A-star.